Familiar with Mentor Graphics. Mentor Graphics is one of the companies, the big companies that play in that field, the electronic design automation field. EDA historically deals with building software tools that are used for designing the chips, the IC chips. And most of these software tools implement different algorithms to solve different problems. And typically the algorithms are very deterministic. They try to be efficient, solve very difficult problems. In recent years, obviously the complexity of the chips that people are designing are becoming obviously very complex, and the amount of data that we have to deal with is becoming enormous. So there are lots of problems where you're faced with enormous amounts of data, and there is no good algorithmic way of trying to figure out a solution to what you're looking for. The solution is really in the data. The problem is there's lots of it. So data mining is a field where you can examine vast amounts of data to try to analyze and try to come up with good, very quick rules to try to solve your problem. And I'm going to go through this. Data mining obviously is not limited to this EDA area, but it's been in use, and I've seen some papers in this conference, like that data mining papers. And historically, it's been used a lot by companies like Google, and mainly in searching for things fast and doing various stuff. It has applications in biomedical and in lots of applications in weather forecasting, and anytime you're trying to look for trends and fast data mining can be used. Okay, so that's my introduction to my title. They told me I have an hour and a half, so I'm going to try to stretch. Okay, so as I said, we're trying to analyze complex data to extract simple and useful knowledge. Okay, so imagine yourself kind of faced with all these bits and pieces of data, and you try to kind of looking for the needle in the haystack, as they say in English. That will enable us to do sensible decision making very quickly, allow us to prioritize our resources, so maybe reorder what we do first, what we do second, and so on, and improve productivity, save costs, and so on by making these good decisions. So I'm going to demonstrate the feasibility of this approach in 5 diverse applications that anybody that has been familiar with design and design automation should be familiar with. Functional design verification, design silicon mismatch and doing analysis in kind of silicon when it comes back after you build it, trying to debug what's going on and so on, what's wrong. Yield improvement, something very familiar to anybody in manufacturing. And the screening of potential customer returns. This is an area for quality kind of control and trying to improve quality. And then finally, cost-effective test and burn-in to try to reduce the cost of manufacturing tests. I'll try to explain these areas kind of. I realize that maybe some of you may not be familiar with the domains, so I will try to explain explain them one by one when I get to them. Okay. Or give you a feel. You don't have to know. I'm trying, the talk here is just to give you a feel for the type of, the power of data mining and where it might be applicable. So the first application has dealing with functional design verification. So functional design verification, you're trying to design a new chip and you have to make sure you verify that it's correct. Same thing like when you're writing a new program and you have to verify that the program does what intended function of the program. Okay, so how do we do that? How do we verify that something is correct? Typically you simulate. You have some method for doing simulation, and to make sure that when you apply certain input, the output is what you expect. But how much simulation do you do? As the designs that we're doing gets more complex, simulation cost is becoming very prohibitive. So companies like Intel, AMD, Cisco, NVIDIA, etc., okay, they have the amount of simulation for their designs is becoming the biggest energy sucking task in the universe. Okay, so people worried about kind of like we're not going to have enough energy, enough electricity in California. Guess where most of the electricity is going? To power computers that are running simulation by these companies. Okay, so people will kind of like, really? Yes. So simulation is a huge task that's running thousands or maybe tens of thousands of huge computers 24 hours, and it doesn't stop. And another problem associated with it is that people don't know when to stop. Where they're trying to get higher coverage, they try to make sure that these things are correct. And the problem is that the bug may only be discovered like here. And you've been simulating, and you still didn't see the bug. And you can't stop because you're worried about what might be in the future. So, so we need to simulate more intelligently. We need to kind of perfect example for a good data mining kind of challenge. Can we figure out a way to reduce this, reduce the cost associated with this task? So, one of the approaches that people use to run these simulation is to have what we call random generators. So they generate random tests or random inputs, and then they simulate them. A lot of these things, when you simulate them, what you're looking for is something that catches or like improve the coverage of your simulation. Now you're running